welcome to today's lessons, which is on fractions, equivalent, comparing and cancelling. So, first of all, let's have a little look at this here. So, the first thing you need to think about is the fact that fractions, although they look different and the numbers are different, you do get fractions which look different but are the same. So if we have a little look at this one here, we've got this one here and it says here, how many 6 are the same as 2/3? So here we've got 2/3. I'm going to look here and look across, and here we've got 2/3, and that's the same as 1, 2, 3, 4, 6. So here, if I've got 2/3 like so, this is the same as 4, 6, like that. And you can see that from this diagram here. These are exactly the same. So although they look different, they are equal. So here, what else have we got? How many 9ths are the same as 2/3? So exactly the same one. So how many 9ths we've got here? So here we've got 1, 2, 3, 4, 5, 6. So this is also equal to 6/9. And how many 12ths are in this? Well, in this question, we've got 1, 2, 3, 4, 5, 6, 7, 8 12. So this is the same as 8 12. And all of these, although the numbers are different, they are equivalent. They're exactly the same. Okay. So let's move on to another question. So here we've got 2/3 again, and this is another way of representing this. How can we make it look like something else? Well, what we do is we basically split all of these parts up into 2. So there was 1, 2, 3 parts, and 2 of them were shaded, and now we've got 1, 2, 3, 4 parts, and 6 of them are shaded. Now, there is another way we can do this, because we don't want to have to draw these down every time. So notice here, if I times the bottom by 2, so times that by 2, which is the same as kind of splitting these by 2, then I can times the top by 2 as well, which is the same as splitting the ones I have by 2. So that's going to be equal to times by 2, times by 2. So let's just have a little look at this next one. So here I've got 3/4 this time. So instead of splitting up by 2 this time, I'm going to split this one up by 3. So before I continue, can I show this without drawing the diagram? So I've got 3/4, and I want to split this up into 3 separate parts. So I do this by timesing by 3, and timesing by 3, so 4 times by 3 is 12, and 3 times by 3 is 9. So let's just check that that works for this one as well. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So I've got 9 parts which are shaded, and then 1, 2, 3. So I've got 12 parts in total, which is exactly the same as I've got here, 9/12. Absolutely perfect. So I've got 9/12 here. So can we now do this without having to draw a picture? Well, I think we probably can. I don't think it's too much. I don't think it's too tricky. So here we've got 3/4. So can I write 3/4 with a numerator as 6? So here we've got 3/4. My numerator on this is equal to 6. So what does that bottom one need to be? Well, what have I times this by here? Well, how many times does 3 go into 6? 3 goes into 6 twice. So I've actually times that by 2. So what must I need to times this one by? Well, I must need to times that one by 2 as well. So this must be equal to 6/8. Let's just check that answer. Let's see if we've got that right. Here we go, 6/8, absolutely perfect, brilliant. So let's have a go at another one of these. So this is basically, we're creating equivalent fractions. They are the same, although they look different, okay? So here I've got 3/4. This time I want my numerator to be 15. So what do I need to times that one by? Well, 3, 6, 9, 12, 15. That goes in 5 times, so times by 5. So what do I need to times the bottom one by? 5 as well. So that's going to be the same as 15/20. Absolutely perfect. Okay, let's have a go at one more of these. So what do I need to times this one by? Let's do this one here. So 2/3, and this time I want a numerator of 8. So how many times does 2 go into 8? Well, it goes 2, 4, 6, 8 times by 4, 4 times. So I need to times that bottom by 4 as well. So 3, 6, 9, 12. So 8/12, and they are equivalent fractions. So one more. I'm just going to do this one on the screen. 3 times by, what do I need to times 3 by to get 30? Well, the answer to that is 10. So I need to times the top by 10 as well, which is going to be 20 over 30. Brilliant. So, what I'm going to suggest now is pause this for now. Have a little go at these questions. It shouldn't take you very long, but pause now and have a go at those. Okay, brilliant. Let's have a quick go at these then. So I'm just going to do all of these really quickly. We've got 6 here to go through. I'm just going to do the answers. So the first one, we've got 2 over 3, and we want the numerator on this one to be equal to 15. So what do I need to times that by? Well, that's 5, so I need to times the top by 5, which is going to be equal to 10 over 15 for that first one. Here we've got 5 over 6. I want my numerator to be 12, so I need to times that one by 2, so I need to times the top by 2, which is going to be 10 over 12. Here I've got 3 over 4. I want my numerator to be equal to 9, so times that by 3, so I must times the bottom by 3, so the equivalent fraction here are 9 over 12 is equal to 3 over 4. So that's those top 3. Let's have a go at these next ones. So we're doing backwards a little bit here. So 10 and 3 over 5, still the same thing. So here, what do I need to times this one by? Exactly the same. I need to times that one by 2. So I need to times the top one by 2, which would be 6 over 10. Here, I've got something over 18, and I want it to be equal to a third. What have I times that by? Well, I've times that one by 6. 3, 6, 9, 12, 15, 18. So I must times the top by 6, which is 6 over 18. And the last one, I think we've already seen this one actually. So 3 over 10, and I want the denominator to be 30. So what do I need to times that by? I need to times that by 3. So I must times the top by 3, which is equal to 9 over 30. Brilliant. So that's those 6 questions done. Perfect. So we should hopefully understand now what equivalent fractions are. They are fractions which look the same and are the same. Sorry, they are the same, but sometimes don't look the same. But we know that we can cancel them, just representing them in a different way. So let's have a look now at these next questions. So we can use equivalent fractions. Sorry, we can use some very similar techniques to compare fractions. Now, the problem with comparing fractions is that we're not sure how to compare them unless the denominator is the same. Unless they're split into the same amount of parts, it's really difficult for you to compare fractions. Okay, so what we do is to compare them, we try and find something that the denominator, we try and find a denominator which is the same. So let's have a look at this first one. I've got 1 over 4, and I want to see which one's bigger, a quarter or a fifth. Now you might know this. Some people might just know that a quarter is bigger than a fifth, but I want to prove it. You can't just say a quarter is bigger than a fifth. Okay, so here I've got a quarter, and here I've got 1/5. So the question is, what number do 4 and 5 both go into? Now, if you want just a rule of thumb, you can multiply these, but sometimes there's a number which is smaller than that, which they both go into. Okay, but in this one here, the number that they both go into, well, 4, 8, 12, 16, 20. So they go into 25, 10, 15, 20. So they both go into 20. So I want these to both be over 20. And then you're just following the same pattern. So what do I need to time this by to get over 20? Well, 5 times by something is 20. We did it before. 5, 10, 15, 20. So that's 3. So 3, 4. So times by 4 and times the top by 4, which is going to be 4 over 20. And this one here, we'll have times by 5 and times by 5. So 1 times by 5 is 5, so it's going to be 5 over 20. So which one of these is bigger? Well, we can clearly see that the quarter is bigger, because now they're both split into 20s. We can see that we've got 5 20ths and 4 20ths, so this one here is bigger. So when I write this, we want, now it's always, the way to think about it is 3 dots, and you always want the bigger dots to be on the bigger side. So it's always either 1, 2, 3, or 1, 2, 3. And you always want this 2 to be on its own. You've got 2 dots on one side, 1 dot on the other. And you always want the 2 dots on the side which is bigger. Okay, so if I know that this one here is bigger, I want 2 dots closest to that one. I want 1 dot closest to the other one. So 1, 2 dots, and then 1 dot there, and then we connect them up. And that's how we can say that 1 over 4 is greater than 1/5. Now you don't have to use the dot technique, but sometimes it does help to know a little trick. If you want something which is on the bigger side, you put the 2 dots closest to the biggest one, and you put the 1 dot closer to the smallest one. Let's have a go at the next one then. That was part A. So here I've got 2 over 3, and I've got 4 over 5. So which one of these is bigger, or smaller, or equal, actually? So we want to make the denominator the same. So what number do 3 and 5 what number do 3 and 5 both go into? So let's do it. 3, 6, 9, 12, 15. No, 5 goes into 15 actually, so maybe I can stop there. And then, so 5, 10, 15. So yes, they both go into 15. So I want these both over 15. Like so, because that's the lowest common multiple. That's the number that they both go into. So what do I need to times this one by to get it over 15? Well, that's going to be 3, 6, 9, 12, 15, so times by 5. So I need to times the top by 5, which is going to be equal to 10 over 15. And what about this bottom one? 5, 10, 15, so 3. So times by 3, times by 3, which is going to be 4 times by 3, which is 12. So actually, this top one is bigger. So we'll write it in the order they've done. 2 thirds and 4 fifths. We know that this one's bigger, so we want the 2 dots closest to this. So 2 dots closest to this, and 1 dot close to this one, because this one's the smaller one. Smaller, bigger, and then we can connect them up. And this says that 2 over 3 is less than 4 over 5. You can actually say this the other way around if you want. 4 over 5 is greater than 2 over 3, because this part is greater than this little part here. Okay, it's always worth thinking about how to explain these going forwards and backwards, because 2 over 3 is less than 4 over 5, and 4 over 5 is greater than 2 over 3. Okay, let's do this last one, and I'm going to give you some to have a go at. So here we've got 2 over 5 and 4 over 9. So let's write them down first. 2 over 5 and 4 over 9. So what number do 5 and 9 both go into? Now this is a tricky one. As I said, you can multiply them to always get a value, but sometimes that's not the best number. That's the lowest common multiple. So with this one here, it is actually the multiplication. So 5, 10, 15, 20, 25, 30, 35, 40, 45. So 45 goes into it. And I know that 9 times. And 9 goes into 45 5 times. So it's going to be over 45 and over 45. So what do I need to times this one by? Well, times by 9. Times by 9. 2 times by 9 is 18. What do I need to times this one by? Times by 5. So I need to times the top by 5. So this is going to be 20 on the top, which means that this one here is smaller. This one here is bigger. So let's write them in the order that they wrote them down. 2 over 5, 4 over 9. We know that this one here is smaller, so I want 1 dot close to this one. This one here is bigger, so 2 dots on this one, and then you can connect them up, like so. So 2 over 5 is less than 4 over 9. Brilliant. Okay, so let's have a go at some of these yourself. Now I'm going to ask you to pause this. There are more questions for us to have a go at, because we're going to have a look at cancelling after you've had a go at this. But right now, pause this and have a go at these questions. Okay, I'm going to put the answers on for these. So mark those in green for me. Okay, so we've had a look at equivalent fractions and comparing fractions so far. So with equivalent fractions, we need to see what we're timesing by and then do the same to the top and bottom. And with comparing fractions, we need the denominator the same so we can compare them. So we're going to move on to the last part of today, this session, which is simplifying or cancelling down fractions. So let's just have a little read of what this says. So simplifying fraction is the opposite. So instead of multiplying the numerator and the denominator by the same number to get something bigger, we do the opposite. So we want to make it smaller, and we want to make it the smallest it can possibly be. So we're dividing it until you can't divide anymore. This is what cancelling down is. So remember, we should be getting all of these in our notes. Remember, the only way to learn maths is to do it. So we should be getting all of these questions down. So let's have a go at these ones. Let's have a look at these ones. Now we know that these are all equivalent, okay? But actually, simplify the fraction. Well, what have we done here? Well, we've divided it by 2. Sorry, we've divided it by 3, and then we've divided it by 2. Okay? So we're cancelling it down until you can't cancel it down anymore. We've just got to see what numbers go into this. So it could be 3, it could be 2, it could be 5, it could be 6. We've just got to keep going. A lot of people like to start with 2. Sometimes it's worth looking at getting a bigger number there. So let's have a go at some of these. So I've got 8 questions. Remember, get these down in your notes because the only way to learn maths is to do it. So here I've got the first one, A, which is 4 over 8. So there's 2 ways you can do this. You can either divide the top and bottom. You can see that they both go, 4 goes into both of them. So you could divide straight away by 4. But you might want to halve it. So with this one here, you might want to, and you don't have to do this. You can divide by 2, which is going to be equal to 2 over 4. But then you can simplify this further by dividing by 2 and dividing by 2, which is the same as 1 over 2. Now you can, if you want, just divide both sides by 4. Notice you could have skipped the 2 steps, so you might want to do that. But that's that first one there. That's example 1 of this section, okay? So make sure you're getting these down in your notes. So, example 2. We've got 6 over 9. Now, everybody always tries to just divide by 2, but I can't divide this by 2 because if you note here, remember you can only divide by a common factor and 2 doesn't go into 9. So the next one I'm going to think about is 3. Does 3 go into it? Yes, it does. So 3 goes into 6 and 9. So divided by 3, 6 divided by 3 is 2. 9 divided by 3 is 3. So I end up with 2 over 3. Brilliant. And that's that first one done. So let's have a go at the next one. Example 3. So here I've got 12 over 16. Now you can divide both of these by 2 first of all, but I'd want to try and divide by the biggest number just to make it simpler. And I can see that 4 goes into both of these. So I can divide by 4 and divide by 4. So how many times does 4 go into 12? 4, 8, 12. So that's 3 times. And how many times does 4 go into 16? 4, 8, 12, 16. So that goes in 4 times there, like that. And that's that one done. Brilliant. So let's have a go. Example 4 now. So example 4. This one here. 24 over 36. Now these are getting a little bit harder now. Now what number goes into 24 and 36? Now if you can't think straight away, then it's just do the numbers you can see go into it. So straight away I can see that 4 goes into both of these. So let's do 4 and 4. So divided by 4 and divided by 4. So how many times does 4 go into 24? Well, it goes in 4, 8, 12, 16, 20, 24. So it goes in 6 times. And how many times does 4 go into 36? 4, 8, 12, 16, 20, 24, 28, 32, 36. It goes in 9 times. Okay, so that's 9. Now, actually, I can see that this is very similar to the one up here. Okay, so this can cancel further by dividing by 3. So divide by 3, which is going to be equal to, how many times does 3 go into 6? Twice. How many times does 3 go into 9? 3 times, so 3 over 2. Okay, now with that one, there would have been a quicker way, and the quicker way would have been, well actually it's both of these times together, so it would have been quicker to divide by 12, so 12 goes into 24 and 36, but we can still get there this way, as long as we keep going and keep cancelling. There's nothing wrong with that. Okay, so we've got 4 more questions, and I'm going to let you have a go at some yourself. So, let's have a go at this next one here. So this is example 5. Remember to make sure you get them in your notes. So, example 5 of cancelling. So, 15 over 35. So, what goes into 15 and 35? Well, 5 goes into both of them. They both end in 5. So, let's do that one first of all. So, divided by 5, divided by 5. So, 5, 10, 15. Yeah, brilliant. So, that goes in 3 times. And how many times does 5 go into 35? 5, 10, 15, 20, 25, 30, 35. So, that's 7 times there like that. Does anything go into 3 and 7? Well, no, it doesn't. They're both prime numbers. So, the only things that go into them is 3 and 7 and 1. So, we're just going to leave that one there. Brilliant. So, this next one, example 6. 21 over 49. So what number goes into both of these? Now, it might be quite tricky to see. And the reason this one's quite tricky to see is because it's actually quite a bigger prime that goes into a bigger number with no other factors. And the number that goes into both of these, well, 2 doesn't. 3 goes into this one, but 3 doesn't go into this one, okay? 4 doesn't, 5 doesn't, 6 doesn't, 7 goes into 21, and 7 goes into 49, so 7 is the number. So here, I'm dividing by 7 and dividing by 7. And how many times does 7 go into 21? Well, that goes in 3 times. And how many times does 7 go into 49? Well, that goes in 7 times, so that's that one done. Okay, 2 more. So example 7. So 16 over 36. So what number goes into both of these? Well, you can see that 4 goes into both of these. So let's start with that. So divided by 4, divided by 4. How many times does 4 go into 16? Well, 4 goes into 16 4 times. How many times does 4 go into 36? 4 goes into 36 9 times. Okay. Can I cancel that any further? Actually, no, I can't. So that's it. Okay, so that's that one done. And example 8, probably got too many examples of these, but it doesn't hurt to have too many examples. So 63 over 77, and this is a hard one again. So this one here again is, well, 77 is a 7 go into it, and 63, 7 goes into that as well. So it's actually 7 that goes into both of these. So how many times does 7 go into 63? 7, it's always hard, the 7 times table. 7, 14, 21, 28, 35, 42, 49, 56, 63. So 9 times that goes in. So 9 there. And how many times does 7 go into 77? 7 into 70 goes 10 times. 70 to 77 goes 11 times. Brilliant. 9 over 11. Super. So that's all the examples done there. So, I've actually got some questions for you to have a go at here. There's 10 questions in total, just simplifying. So have a go at these now. I'll put these up. So pause now and have a go at those questions. Make sure you're getting them in your notes. Remember, the only way to learn maths is to do it. Okay, I'm going to pop the answers up. So mark those in green. Brilliant. So if you got all those right, well done. Remember, you do need to have a go at these questions because I keep saying it, but the only way to learn maths is to do it. And thank you for watching this video on fractions, equivalence, comparing and cancelling, and have a lovely day.